welcome to Two Projects. In this video, we are going to explain about the project that is a novel transfer learning framework for multimodal skin lesion analysis. Before getting into the execution, first let us understand what's the project about. So, spotting a new spot or bump on your skin can be concerning, especially when you're unsure if it is just a harmless mole or something more serious like skin cancer. Skin disorders are common health issue worldwide, and the challenge lies in the fact that skin lesions can look very different from one another, varying in size, shape, color, which makes it difficult to quickly determine whether they are benign or malignant. Doctors they often turn to tools like dermoscopy to closely examine these lesions. So they use dermoscopy to look at these lesions, but even with a specialized tool, making an accurate diagnosis can be challenging. So here the problem is compounded by the fact that dermoscopy typically relies on single type of image, which may not capture all the crucial details needed for a clear diagnosis. Additionally, the process is quite subjective. What one doctor sees in an image may differ from another interpretation. Even experienced dermatologists can sometimes make mistakes leading to misdiagnosis. Despite advances in diagnostic technology, this leaves room for improvement, highlighting the need for a more reliable, multi-phased approach to ensure skin conditions that are detected and treated accurately in the early stages. And one of the major challenge hurdles in improving skin lesion diagnosis is the lack of diverse, well annotated data sets. Most automated systems rely on a large amount of data to learn and make predictions. But when those data sets aren't varied enough or properly labeled, the system struggles to accurately recognize skin conditions across different populations and skin types. For example, sometimes some systems might perform well on fair skin but fail to identify lesions on the darker skin tones simply because when they haven't been trained with enough diverse examples. This means that the existing automated tools aren't effective or universally applicable as we need them to be. And the issues highlight the bigger picture. Traditional methods, while useful, have their limitations. Not only they do struggle to handle diverse skin conditions, but they also put a significant strain on healthcare professionals who have to spend a lot of time analyzing images annually. What's needed is a diagnostic approach that goes beyond these existing shortcomings, one that can improve accuracy, reduce the burden on doctors, and offer scalable solutions for diagnosing skin conditions effectively and reliably across all types of patients. So, to overcome with all these issues, this project introduces a new approach that combines multiple methods to improve how we analyze skin lesion. So, here a deep learning model, that is transfer learning model, VIT, that is vision transformers, has been proposed, which is a model that works really well when it comes to understanding complex patterns in the images. Unlike older methods, VITs can capture more detailed relationship between parts of an image, helping them to spot skin conditions more accurately. And what is really cool about the system is that it doesn't just rely on one type of image like dermoscopic images like traditional methods do. Instead, it uses mix of different images like dermoscopic and macroscopic images. So, by bringing together all these different perspectives, the system can provide a more comprehensive and accurate analysis, overcoming the weaknesses of using only one kind of image. And to make sure that model performs well on across different scenarios, the system uses data augmentation techniques. That is, rotating, flipping, zooming in on images. This helps the model to learn, generalize better, meaning it is less likely to make mistakes when it encounters new unseen data. It also helps to tackle the issue of class imbalance, where some types of lesions might be underrepresented in the data set. Then, for performance, that is, the system's performance is tested by comparing it to more traditional models that are support vector machine, that we call as SVM, and other deep learning models that are MobileNet, ResNet 152v2, and VGG16. So this is all about the proposed system. Moving on, to further improve the performance, here we have added an extension part where we have incorporated two different models. One is exception and the other one is voting classifier. So here exception is a deep learning model that is known for its excellent performance in image classification tasks. So it is used for extracting important features from the image. And then we have applied voting classifier, which is an ensemble approach to classify the skin lesion. So it combines multiple model predictions and make a final prediction. This approach pulls the strength of different classifiers together, making the overall system much more accurate in classifying skin lesions. And here we have also added a detection part where we will be localizing where that skin lesion on the image. For that, we have used YOLO, that is, you only look once, family, that is various versions of the YOLO. And we have also added in front end part. So we have built front end using Flask framework. So this allows users to easily interact with the system and test how well it works. And we have also added a user authentication mechanism. This allows users to interact with the system and test how well it works. So this is about the extension. Now moving on to the implementation. To implement this project, we have followed certain set of steps for classification and certain set of steps for detection. Let us understand what are the steps that we have followed. So first, what we have done is we have imported all the necessary libraries, frameworks that are needed for data processing, model building, and execution. Then comes the exploratory data analysis part. So here we understand the structure and content of the data set to ensure it is ready for pre-processing and analysis. Then comes image processing. So here we have enhanced the transforming by using image data generator for training, applying various techniques. So we have done all this pre-processing steps using the image data generator library, where we have rescaled the image, that is we have adjusted the pixel values of the image to a standard range. And then we have applied shear transformation, that is geometric transformation, to shift or distort the image. Then comes zooming the image. So we have enabled zooming effects to create variations of the image. And then we have flipped the image horizontally to augment the dataset. And we have adjusted the image size to fit the model's input requirements. Then comes feature extraction. So here we have extracted features using CNN model exception. We have told you in extension part, right? So we will be using exception for feature extraction. So this is that part. So here what we do is we load all the images data for processing, and then we change the image color. So we change the image dimensions for consistency, and then we convert the image color space if necessary, that is from BGR to RGB. Then we append the image labels. So here we sort the images along with their corresponding labels, and we convert all them to the NumPy array value. After that, we will encode the labels. That is, we will convert all the labels into numerical format for model training. Then comes building the model part. So here we construct the architecture of the neural network to perform classification. And then we will be training the data with the trained model, with the constructed model, so that it will identify patterns from the training data. And then the best performing model will be saved for the future use for classifying skin lesions. So this is how we have implemented the classification. Then coming to the detection part. So here we have imported all the required packages similarly to the classification. So here also we have imported all the required libraries, that is for loading the models, processing the images, and for detection purpose. Then comes exploratory data analysis. So here we load the image for detection and display the image for visual analysis. And here also we do basic image processing, where we convert, that means where we transform image to blob format, that is that is suitable for detection. And then we define the class, that is setting the classes or categories in which the detection result will fall. And then we declare the bounding boxes, that is specify the region in the image where an object or feature is located. And then we convert image to a NumPy array. Then comes loading a pre-trained model. So here we understand the structure of the neural network and identify the layers that provide the final predictions. Then we do basic pre-processing again. So here we associate, that means we append all the image annotation files, that is associate images with their corresponding labels, and we change the image color format from BGR to RGB. We generate a mask to highlight the regions of interest within the image, and we adjust the image size to the detection model. Then comes data augmentation, where we apply randomization, we rotate the images, and we do apply the transformations for better generalization. Then comes building the model. So here we design and construct the detection model to process the images and detect abnormalities. Then comes training the model. So here we teach the detection model to identify patterns and features in the images. And we save the best performing model for detection purpose. Then comes the part of front end. So here we have developed the front end using Flask framework. So we have developed front end using Flask framework, and we have included setup, login, and registration features backed by a database. So users, they can upload images for classification and also for the detection. And then that given input, that given image will be pre-processed at the backend. It will be fed with the trained model. Finally, outcome will be displayed to the front end of the application. So this is how we have implemented. And now moving on to the algorithms used. These are the algorithms used in this project for classification purpose. So these are the models trained on the data set for classifying the skin lesion. And these are the models used for detection. That is YOLO V5X6, YOLO V8, and YOLO V9. And to implement this project, we need basic requirements that are hardware and software. Coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. So to execute, we are supposed to open the code folder that contains source code files. Let's open the code folder of the project. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? Let's open the dataset folder. So here are the different skin lesions that we have in each respective folder. So here we have actinine keratosis skin lesion. So here these are the images of actinine keratosis. So these are the images. Let's get back. And here we have basal cell carcinoma. So these are the images of basal cell carcinoma. So these are the skin lesion, which is called as basal cell carcinoma. Let's get back. And here we have benign keratosis. So these are the images of benign keratosis where a person is affected with the skin related to benign keratosis. Similarly, we will be having in the all other folders also. Let's get back. And the images which are in this folder are used for classification purpose. And that images are split into two subfolders. One is train and the other one is valid, where we will be using train folder to train the model and validation folder to evaluate the model. And let's get back. So here in the sample folder, we have two subfolders. One is classification and the other one is detection. So images which are in the classification folder, we will be using for classification, and images which are in the detection folder will be using for detection in the front end. We will be testing there. And here in the static folder, we have files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here in the templates folder, we have HTML files in it. So these are important for the project. And we have index.html, about.html, etc., which will be represented in the different pages of the website. And here in the YOLO v5 folder, we have the dataset used. So here we have train and test folders. Let's open the train folder. So here we have images in two subfolders. One is images and the other one is labels. Let's open the images folder. So here are the images that are used to train the YOLO v5 model. So these are the different skin lesions that we will be using for training the YOLO v5 model. Let's get back. And locations of those skin lesions. So here in the front end, we will be detecting skin lesion, right? So that location will be having in the label folder. Let's open this label folder. Here, label folder contains the file annotations or the it will contain the annotations or labels for the objects in corresponding images. So here, each label file, it corresponds to an image file in the image folder. For example, this file, it corresponds to the first image in the image folder where it highlights where it detects the skin lesion. And for the second image, we have second annotation file. Accordingly, for all the images in the image folder, for all the 799 images, we have 799 annotation files. Here, label files, they follow the YOLO format. Let's open a file for sample. Here, this line represents a detected object, which is followed by object class index, and that is followed by bounding box coordinates, which are x limit, y limit, width, and the height. Similarly, we will be having in all the files. Let's get back. And here, train folder is used to train the YOLO v5 model, and test folder is used to evaluate the YOLO v5 model. Let's get back. Accordingly, we will be having same images in YOLO v8 and YOLO v9, but they are annotated differently because each YOLO version requires its own specific type of image annotations for training and testing the models effectively. Having separate folders helps keeping the dataset organized, ensures that each YOLO version receives the correct annotations that it needs to function properly. And here we have app.py file. So this .py file contains the information related to front-end logic, and it includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the model file in which we have the algorithm information stored that will be loaded into the project code during runtime of the application. And these two are also the model files. And these two are the Jupyter Notebook files, which contain the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here in this classification Jupyter source file, we will be loading all the images for classification. That is, we will be training all the models just to tell what is the images, which type of skin lesion the person has. And coming to the detection, here we will be loading, we will be loading all the images which are in these three folders, and we will be training the model to detect, to spot where that skin lesion is on that image. So this is about the Jupyter source files. And now coming to the signup.db file, this file is a database file which is used to store the user information. This is about the code folder. Now let's execute. So copy the path from the code folder of the address bar. So copy it. Now open the Anaconda prompt. So give the command cd, give the space, paste the copied path. Now click on enter. So current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port, unless configured differently. Just wait for a while. File is being loaded. File is being compiled. So here localhost has been generated. So the application has been hosted at the default address, that is the localhost and the port. So now copy this local link provided by the Flask framework and paste it into any web browser. I'm copying it. I prefer Google Chrome, so I will paste it in that. So paste the link here, click on enter. This is the web page of the project, which is displayed in the browser. This is developed using Flask framework. So first we need to get signed up. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so directly sign in. Click on sign in and give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. That is classification page of the project. So here we will be doing classification and detection. So first we are defaultly redirected to classification page. So here you can see a choose file button, right? We need to click on that for uploading the images. So click on choose file. Now open the sample folder. Here we have two subclasses. One is classification and the other one is detection. Let's open classification. So these are the images that we are supposed to upload now. So let's open images which are in this folder. So let's upload this one. Click on open and now upload it. This image will be pre-processed at the backend and then it will be fed to the train model. Train model will be giving us the prediction. So here we got the prediction. This is the uploaded image and here we got the prediction that skin cancer type is actinic keratosis. So here this is the uploaded image and here we got the prediction as skin cancer type is actinic keratosis. So the person with this image is suffering with this actinic keratosis. Now let's try uploading one more image of the other class. Let us upload the same, image from the same class. So let's upload this one. Click on open and now upload it. So here we got the prediction. This is the uploaded image and here we got the prediction that skin cancer type is actinic keratosis. So here we got the correct prediction. Let's upload images from the other folder. Click on choose file. Let's get back. Let us upload from this folder. So let's upload this image. Click on open and now upload it. So here we got the prediction. This is the uploaded image and here we got the prediction that skin cancer type is basal cell carcinoma. So here this is the uploaded image and here we got the prediction that basal cell carcinoma has been predicted. Now let's try uploading one more image. So let's upload this one. And here we got the prediction. This is the uploaded image and here we got the prediction as basal cell carcinoma. It is the basal cell carcinoma. Now let's upload image from the other folder. So let's open this folder and let's upload this file. That is this image. And here we got the prediction. This is the uploaded image and here we got the prediction that skin cancer type is benign keratosis like lesions. So it is this cancer type. Now let's upload one more image. Click on choose file. Get back. Let us upload from this folder. Let's upload this image. So here we got the prediction. This is the uploaded image and here we got the prediction that it is dermatofibroma. It is dermatofibroma skin cancer. Let us upload one more image. So now let's upload this image. Let's upload this image. Click on open and now upload it. Here we got the prediction. This is the uploaded one. And here we got the prediction as dermatofibroma. Let us upload some more. Click on choose file. Get back. So let's upload this image. Click on open and now upload it. And here we got the prediction. This is the uploaded image. And here we got the prediction as melanoma has been predicted. It is the skin cancer that is melanoma. Let us upload some more images. Click on choose file. Let's get back and let's upload this folder. Let's upload this image and upload it. So this is the uploaded one. And here we got the prediction that it is melanocytic nevis. It is melanocytic nevis. It is. Now let's upload some more. Click on choose file. Let's upload this one. So here we got the prediction. This is the uploaded image. And here we got the prediction as melanocytic nevi. It is. Let us upload some more images. Click on choose file. Get back. We are supposed to upload this image. Let's click on open and now upload it. And here we got the prediction. So this is the uploaded image and it is of vascular skin lesion. It is a skin cancer that is vascular lesions. So in this way, you can do classification. Now let's check with the detection. Click on detection. So click on choose file. Get back. Open detection. Let us upload this image. Click on open and now upload and detect. So here you can observe that a vascular lesion has been detected and a green color bounding box is drawn around the area where that skin cancer is present. You can observe, right? A green color bounding box is drawn. And here we have a probability score, which is the confidence level that how accurate the detection is in detecting this particular class that is vascular. Let's get back and upload some more. Click on choose file. So now let us upload this image. Click on open and now upload and detect. So here you can observe that basal cell carcinoma has been detected and a green color bounding box is drawn around the cancer where it is present. You can observe, right? It is locating where is that disease. Let's get back. Click on choose file. And now let's upload this image. Click on open and now upload and detect. So here you can observe that melanoma has been detected and a bounding box is drawn around that. So here you can observe, right? A green color bounding box has been drawn and it is labeled it as melanoma with the probability score. Let us get back and upload some more. Click on choose file. And now let's upload this one. Click on upload and detect. So here you can observe that a green color bounding box is drawn around melanoma. Let's get back. Click on choose file. So now let's upload this one. So here you can observe that benign. It is a benign keratosis and a bounding box is drawn around it. Now let's get back. Click on choose file. So now let's upload this one. Here you can observe that melanoma has been detected. Let's get back. Now let us upload. Let's upload this one. So here basal cell carcinoma is detected. In this way, you can do detection with all the images. Now let's check with the graphs. Click on graph. So here, the first graph which we have is the accuracy comparison graph. So this is for classification. So the first graphs we have is the classification graphs. So this is the accuracy comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithms that are trained. And this is the precision score. This is recall score. This is F1 score. This is specificity score. And here we have sensitivity score. And these are the graphs of detection. This is the precision recall curve graph. This is the F1 confidence curve graph. And this is the confusion matrix. Here we have precision score, recall score comparison, and mean average precision comparison graph. These are the models trained for detection purpose. Now click on sign out. So here You can observe, right, when we have uploaded the image for the classification, it has just classified what is that skin cancer type is. When we have uploaded image for detection, it has identified what is that skin cancer, and it has also spotted where is that skin cancer on image, where is that skin cancer on image. So this is what the difference between classification and detection. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.